In this video, I will present our paper, I Think I Don't Feel Sick, exploring the relationship between cognitive demand and cybersickness in virtual reality using fnirs. We all know that virtual reality is going to become a big part of our lives in the future, but one major drawback of VR is cybersickness. The experience of cybersickness results in symptoms similar to traditional motion sickness, with users experiencing headaches, dizziness, and nausea when using the devices. There has been a significant amount of research conducted into VR cybersickness and different mitigation strategies to overcome it, with most of it focusing on investigating the effects of sensory input on symptoms, so looking into what is visually presented and how different types of visual stimuli can affect motion sickness. For example, field of view restrictors and changes in speed of visual motion have been examined to affect cybersickness. Varying the visual environment in such a way can overcome cybersickness, but also diminish the experience of the user by reducing presence or even leading to disorientation. But research has also found that there seems to be a relationship between cognitive processes as well as cognitive demand and cybersickness. Many VR applications already involve an aspect of cognitive demand, for example in VR games, as well as in training and treatment applications used in the medical sector or for work. Therefore, it is important to investigate the relationship between cognitive demand and cybersickness, as this could help develop new and possibly more suitable cybersickness mitigation techniques. For example, one's belief about their own self-motion displayed in VR being possible can affect the experience of cybersickness. If someone believes that they could possibly be physically moving in the same way as they experience to be moving virtually, for example when sitting on a moving chair, the experience of cybersickness is reduced. Similarly, when engaged in a mental task, while exposed to a sickness-inducing stimulus, we experience less severe motion sickness than when we are not mentally engaged. Even listening to music can help reduce motion sickness, particularly when listening to music that is enjoyable or one's preferred type of music. Even performing a simple counting task can help reduce motion sickness symptoms. On the other hand, motion sickness can also affect cognitive processes. When experiencing motion sickness-like symptoms, performance on cognitive tasks is negatively affected, meaning that when we are feeling sick, we perform worse on mental tasks. These findings suggest that cognitive tasks do not simply distract from adverse symptoms, but that higher cognitive processes are involved in the experience of motion and cybersickness. Cybersickness is generally measured using questionnaires and rating scales. These can be cumbersome to fill out, lack the ability to determine temporal development of sickness, and can distract from the virtual environment and break presence, highlighting the need for physiological measures of cybersickness. EEG has previously been used to identify neural correlates of motion and cybersickness and has helped to identify brain areas involved in the experience of sickness. During the experience of motion and cybersickness, mostly posterior brain areas such as the occipital and parietal cortex are activated, with some work finding activity over frontal areas as well. EEG is, however, rather cumbersome to set up, which is why we are proposing fnirs as an alternative measure of cybersickness, as it could be more easily integrated into VR headsets in the future and is likely more comfortable for the user as it is portable and non-invasive. fnirs has been widely used in the HCI community and is an established measure of cognitive demand, for example when performing different types of visual attention tasks, with more mentally demanding tasks resulting in higher brain activity over frontal areas. Based on the literature, we predict that the experience of cybersickness is governed by higher cognitive processes and therefore relies on similar processes to those needed to perform a cognitive task. We therefore expect that the experience of cybersickness will also be reflected in neuronal changes found in the frontal lobe area of the brain and not just in changes over the posterior regions. In our experiment, participants were seated on a virtual roller coaster and experienced a typical ride with up and downward motion as well as loops resulting in a sensation of being upside down. While experiencing this ride, participants performed a cognitive task, which relates to the little monsters that you can see here in the displays. The cognitive task performed by our participants was a rapid serial visual presentation task. The little monsters presenting both targets and distractors. Before each round, 2 of the monsters were introduced as targets, and whenever they appeared, participants had to press a button on the controller. Every round, 2 different monsters were targets so that participants didn't get used to any of the monsters as being targets. The monsters were also presented at a rate of 2 Hz, meaning that they were visible for 500 milliseconds before a new one appeared. As part of the study, we were interested whether performing a cognitive task would reduce cybersickness. Therefore, participants were either instructed to react to the 2 targets presented while riding on the roller coaster and rating their level of cybersickness, or they were asked to simply use the monsters as a fixation point and rate the experience of cybersickness. At the same time, we wanted to identify neural correlates of cybersickness. Therefore, participants were either seated on a moving roller coaster, which is expected to induce cybersickness symptoms, or they were seated on a stationary roller coaster. This resulted in 4 conditions in total. 2 conditions in which the roller coaster was in motion. In one of them, the cognitive task was being performed, and in the other one, it was not. And 2 conditions in which the roller coaster was stationary. Again, in one of those, the cognitive task was being performed, and in the other one, it was not. Each condition was presented 2 times for 3 minutes each time. As expected, participants rated the experience of cybersickness higher in the moving conditions, both on the FMS scale as well as the Simulator Sickness Questionnaire, meaning they experienced more severe cybersickness symptoms when on a moving roller coaster. Interestingly, performing the cognitive task affected cybersickness on the FMS scale and SSQ differently. While being on the roller coaster, participants rated the experience of cybersickness lower when they were simultaneously performing the cognitive task. However, after the experience had ended, they rated the overall experience of adverse symptoms higher on the Simulator Sickness Questionnaire when they had been performing the cognitive task compared to when they did not perform the task. These findings would suggest that the FMS scale and the SSQ measure slightly different aspects of cybersickness. The FMS scale was also applied throughout the experience on the roller coaster, while the SSQ was applied after the experience had ended, suggesting that our results could reflect temporal differences in participants' experience of cybersickness, possibly including differences in the recovery times for conditions. In addition, performing the cognitive task and the experience of cybersickness could be more fatiguing than only being seated on the moving roller coaster without performing the task, which could be reflected more in the post-hoc SSQ scores compared to the FMS ratings. Now let's look at our fnirs results. When investigating brain activity reflecting cognitive demand, we firstly compared the 2 conditions in which the roller coaster was stationary. This allowed us to investigate the neural activity for cognitive demand separately from any effects of cybersickness. We conducted our analysis, both including only the first 60 seconds of each condition and also the full 3 minutes of each condition. For both of these analyses, we found higher brain activity over the right dorsolateral prefrontal cortex in conditions including the cognitive task. These findings are in line with previous research, suggesting higher frontal brain activity in relation to increases in cognitive demand. Similarly, when investigating the neural correlates of cybersickness, we firstly compared the 2 conditions in which participants did not perform the cognitive task, allowing us to investigate the neural activity of cybersickness or motion separately from any effects of cognitive demand. Again, we performed these analyses for the first 60-second time window of each condition and for the full 180 seconds. We found higher brain activity in the right dorsolateral prefrontal cortex in conditions in which the roller coaster was moving compared to stationary conditions, but only when comparing the full 3 minutes of each condition and not for the first 60 seconds. This would suggest that the brain activity found here could reflect changes in cybersickness rather than just a perception of self-motion, as these were higher towards the end of the condition. When participants performed the cognitive task in the presence of VR motion, brain activity over the right dorsolateral prefrontal cortex dropped. This result was significant when compared to all other conditions. This result could also reflect a cap on attention resources in a dual task condition such as this one, potentially reflecting either a reduction or redistribution of available cognitive processing resources, which resulted from an interaction of the processing of cybersickness and the cognitive task. This could also explain the reduction in task performance when experiencing cybersickness. To sum this all up, in conclusion, our findings suggest that cognitive demand can reduce the experience of cybersickness and that the same frontal brain areas are activated for both cognitive processes as well as the experience of cybersickness, suggesting that rather than a cognitive task simply distracting from the experience of cybersickness, decreases in cybersickness may be due to these 2 processes sharing the same attentional resources, highlighting a complex interrelationship between the processing of cybersickness and cognitive demand. These findings can help guide the development of VR applications, highlighting the need to consider the mental demand of a VR task when trying to mitigate cybersickness, and highlighting the potential of fnirs as a measure of cybersickness. If you have any more questions, please have a look at our paper or come find me at Kai in Hamburg.